Seesaw is a swing made of board balanced at the center. Ron, John and Matthew are trying to take position on a seesaw. They have similar weights. Ron and Matthew go to one side and John on the other. Oh, it has tilted onto one side. Sam comes and sits with John. Wow, now it is stable and balanced because it has equal weights on both sides. Similarly, the chemical reactions taking place around us or carried out by us and scientists occur according to law of conservation of mass, and hence they are always balanced. Let us learn how we can balance chemical equation. Methane is main constituent of biogas. When it burns in the oxygen or air, it forms carbon dioxide and water vapor. We can represent it like this. Is it a balanced chemical equation? No, because the number of atoms of the elements on both the sides is not equal. Let us learn how to balance a chemical equation. While balancing a chemical equation, it must be taken care that the coefficients are added in front of the molecules and not as subscripts so that the compound remains the same. For example, on adding 2 to the subscript of oxygen in water, it will change water to hydrogen peroxide. Coming back to our question, for balancing a chemical equation, let us first write the formula of reactants and products. Next, we need to list the number of atoms of all the elements present in the equation. So, count the atoms on both the sides and write them in a table. There are 1 carbon, 4 hydrogen and 2 oxygen atoms on the reactant side and 1 carbon, 2 hydrogen and 3 oxygen atoms on the product side. Generally, balancing of a chemical equation starts from the compound that has more number of atoms. And in that compound, it is started with the element that has maximum number of atoms. So, we have to start with number of hydrogen in the methane molecule, and for balancing the hydrogen atoms, multiply water by 2. That is, write 2 as a coefficient of water. Count the hydrogen atoms on both sides again. For balancing oxygen atoms, multiply O2 by 2. Now count the number of atoms of each element on both the sides. This time, all the atoms on the reactant and the product side are balanced. Now, write the physical states of the reactants and products along with their chemical formulae. This is a balanced chemical equation. Let us balance another chemical reaction to check our clarity on the topic. Aluminium and water react to form aluminium oxide and hydrogen gas. The symbol equation can be written as. Recall that first we need to count the number of elements present on the reactant side and on the product side. So, there are 1 aluminium, 2 hydrogen and 1 oxygen in the reactants, and 2 aluminium, 2 hydrogen and 3 oxygen in the products. Since the number of atoms in the reactants and products is not same, the reaction is not balanced. Let's balance this equation. For balancing oxygen atoms, multiply H2O by 3, that is, add 3 as the coefficient of water. For balancing aluminium atoms, multiply aluminium by 2. For balancing hydrogen, multiply H2 by 3. Remember, we have to write 3 only as the coefficient of H in H2. Now, count the number of atoms of elements on each side of the arrow. And finally, count the number of atoms of each element on both the sides again. This time, all the atoms on the reactant and the product side are balanced. Therefore, the equation is said to be balanced. Now we will rewrite the balanced chemical equation with physical states of reactants and products. Here, S, L and G written in the brackets in the reactants and products represent the solid, liquid and gaseous state. In some reactions, conditions such as temperature, pressure, catalyst etc. are also mentioned. They are indicated above and below the arrow in the equation. For example, production of methanol and reduction of methanol to methanol.